Hello. So this is lesson 4.3, and we're going to continue with the logs. Now we're going to talk about the properties. So we're going to start with the product rule. So we have b, m, and n, all positive real numbers with b cannot equal 1. And the product rule will be log with base b of m times n. And notice that m times n is inside parentheses to show that that is part of the log. This is the same thing as log with base b of m plus log with base b of n. So let's go ahead and look at an example. We have the log with base 6 of 7 times 11, and we're going to use the product rule to expand this log expression. So we're going to rewrite it as, log with base 6, the base does not change, of 7 plus log with base 6 of 11. And that's it. This common log here, again, the base does not change, so we're going to use the common log of 100 plus common log of x. And now we can calculate the common log of 100, which is going to be 2. So our answer would be 2 plus common log of x. Now, how did we know that it is 2? Because common log is the one with the base 10. We're trying to figure out what exponent we raise the 10 to for it to equal 100, and that was 2. So that's where this 2 comes from, just as a reminder. Okay, next rule that we're going to look at is the quotient rule. Excuse me, I've got something in my throat right now. Okay, let's see if a drink of water helps. So let b, m, and n again be positive real numbers with b does not equal 1. Quotient meaning that it is a division. So base is b and the quotient is m over n. This is the same as difference of the logs. So again, the base does not change. So log with base b of m minus log with base b of n. Okay, let's look at an example. So we have a log with base 8 of 23 divided by x. So this one, when we expand it, it would be log with base 8 of 23 minus log with base 8 of x. And we're going to have to leave it in this form because there is no such exponent that we would raise 8 to for it to equal 23. So it'll stay in that form. This next one, we have a natural log and an e. So natural log e to the power of 5 minus natural log of 11. Actually, we're going to leave it in this form for now and come back to it in a little bit because we're going to look at the power rule. And now, power rule first before we actually go farther with that. So we have b and m are positive real numbers with b does not equal 1 and p is any real number. So what this means is we have a log with base b of m to the power of p. Now, this p right here, which is the exponent, we can bring it down to the front. P times log with base b of m. Okay, now going back to our previous example, if we look at this part right here, we have the exponent 5 over here. So what we can do is we can bring the 5 to the front like we did in the or using the power rule. And then we have a natural log of the natural base minus natural log of 11. Well, now natural log of 11 of not 11, natural log of the natural base is 1. So we have 5 times 1 minus natural log of 11. So we end up with 5 minus natural log of 11. Okay, so we've got a couple of examples with using the power rule, even though we just did one example with it. Um, so log with base 6 of 3 to the power of 9. What we're going to do is we're going to go ahead and bring the 9 to the front and rewrite log with base 6 um, of 3. And now this this we can't simplify it any farther because there is not a whole number where 6 to the power of something would be a 3. Okay, let's look at the next example here, which we have a natural log and we have a cube root. Now, remember that we can rewrite the cube root with an exponent. So cube root is the same thing as to the power of 1/3. And now we can bring the 1/3 to the front. So 1/3 natural log of x. And that would be our answer. This next one here is a common log of x plus 4 squared. So we would just bring the 2 to the front and rewrite common log of x plus 4. And again, notice that the difference between this and if we have a common log of x plus 4 squared without parentheses. This would mean that this is only the log and this is separate. So this would be common log of x plus 16. So the parentheses here tell us that the x plus 4 is with the log. Same thing, it doesn't matter if it's an addition, subtraction, multiplication. Um, the parentheses show that it's part of the log. Okay, so let's combine the properties for expanding log expressions here. So m and n are greater than 0. So our product rule is log base b of m times n equals log base b of m plus log with base b of n. The quotient rule is log with base b m divided by n. That's the quotient, the division. So that becomes a subtraction. So log with base b of m minus log with base b of n. Then one on the top, so the m is the first, and then we subtract whatever's on the bottom, the n. Okay, then we have the power rule, log with base b, m to the power of p. We can bring the p to the front and keep the rest, log with base b of m. And you'll see why we're doing these rules and what we're going to be using them on. So we're going to use the log properties to expand the expression as much as possible here. Um, again, all this is inside parentheses, so we know that the whole thing is part of a log. Remember that there's a multiplication here, so we're going to use the product rule first here. So product rule to expand first. So log with base b, x to the power of 4 plus log with base b, cube root of y. Next, we have exponents here. We have a 4. So we're going to use the power rule. We're going to bring the 4 to the front. So 4 log with base b of x. Now, remember what we did with the cube root. We can bring the 1/3 to the front, log with base b of y. And that would be the expanded form. So again, the cube root of y is the same thing as y to the power of 1/3. Okay, let's look at this one. This is a little bit more complicated here. We have, or what we're going to first use is the quotient rule. So even though there's a lot of other things going on here, the quotient rule is the kind of the main or the first part here. So log with base 5, square root of x, I'm going to rewrite the square root of x as an exponent with a half instead of the square root. And then we are subtracting what's down here. So log with base 5 of 25y cubed. And all this is inside parentheses. Okay, well now we're going to use the product rule. And we're using it for this part right here. So everything else is, or this part is going to stay the same, minus, now we're going to use parentheses because we have the minus in front and we've got everything else is happening kind of after it. So log with base 5 of 25 plus log base 5 of y cubed. Okay, next what we're going to do is we're going to distribute the negative over here. Distribute the negative sign. So this does not change yet. And we're just switching the signs over here to get rid of that. The parentheses. There we go. And now we have all these exponents. So what we're going to do, actually, before we get rid of the exponents, what we want to do is we're going to rewrite this 25 with the exponent as well. 25 is the same thing as 5 squared, right? So I'm going to go ahead and change this to 5 squared. Now, we are going to use the power rule and bring the exponents to the front. So half log base 5 of x minus 2 log with base 5 of 5 minus 3 log 5 with base y. Okay, we can still simplify. This here is going to equal 1. So we have half log with base 5 minus, or x of x, minus 2 minus 3 log with base 5 of y. And that is your expanded form. So these were all for expanding, right? Well, now we're going to look at condensing. So properties for condensing. Well, the properties are the exact same. They haven't changed. So we're going to go ahead and use the exact same properties or the rules, product rule, quotient rule, and power rule that we did for the expanding. We're just going to go kind of go backwards. So the quotient is where we get the difference. And then our power rule is where we bring the exponent to the front. Okay, so here's our first example where we need to write it as a single log. One thing we have to check before we do anything else is that they are the same bases. So if you look at these, yes, they are. It is a base 10. So we're going to go ahead and since bases are the same and it is an addition, we are using the product rule backwards. So we're going to rewrite it as common log of 25 times 4. Well, common log of, or 25 times 4 is the same thing as 100. Now, we can rewrite this as common log of 10 to the power of 2. Use the power rule to bring the 2 to the front and do common log of 10, which we know that this equals 1, so our answer is going to be 2. Okay, next one. Now, here, 7x plus 6 is an addition. We can't do anything about it. It's going to stay as it is. Um, Remember that if when we have an addition, we are adding two logs. Here, we're just adding 7x plus 6. So all we can use for this one is the quotient rule because it has that they're both common logs, so the base is the same, and there's the subtraction in between. So this would be common log of 7x plus 6 divided by x. Okay, let's look at this next example. And now there is a mistake actually here. There should be an the natural log in between here. So it actually should be 2 times natural log of x plus 1/3 natural log of x plus 5. Should look like this. Again, our goal is to write as a single log. So what we're going to use first is we're going to use the power rule. We have the 2 and the 1/3, so we're going to go backwards and put those into the exponents. So natural log of x squared plus natural log of x plus 5 to the power of 1/3. Now we have an addition here, and the bases are the same because they're both natural logs. So we're going to go ahead and use the product rule. So natural log of x squared, we need parentheses now, and x plus 5, and I'm going to rewrite it as the cube root. Oh, the 2 is too close. Here we go. And that would be our answer to write it as a single log. Okay, next we're going to look at the change of base property. This is something that you will need to calculate the logs because the calculator doesn't have anything else except the natural log and the common log. So if we have a log with base b of m, we can rewrite it as two logs over each other. What happens is that we're changing the base. So the base changes to, for example, a common log or a natural log. And the m goes on the top, and this base here, the b, goes on the bottom. So, for example, for the change of base property, if we want common log, so we have log with base b of m, this would be common log of m over common log of b. Now we could plug it in the calculator because it's common logs and we have the common log in the calculator. Same thing with the natural log. Instead of log with base b of m, we can write it as natural log of m divided by natural log of b. So we are going to use common logs or the common log to evaluate this one right here. So we've got log with base 7 of 2,506. Now we're just going to rewrite this with the common log of 2,506 divided by the common log of 7. Now we can plug it in the calculator using the common log button and we get 4.02. We're going to do the same thing. So this is the exact same log, but now we're going to use the natural log. So log with base 7 of 2,506 equals the natural log of 2,506 divided by natural log of 7. When we plug it in the calculator and use the natural logs, we get the exact same answer as we did with the common log. So we'll look at when to use which one, but basically you just need to know that they both give um, the exact same um, answer, regardless of if we're using common logs or natural logs. Okay, that's it for this lesson. Let me know if you've got any questions. Bye.